turn it on over here, right? Do you know where the cables go after that? So we have 4 SMUs, right? Our power units. Do you know where they go from there? Can you show me?
Not quite. I actually can, because this is fresh in my mind.
Okay.
And we did this last year, but basically we just trace these 3 probes and just traced it to the back, but basically they go to the back of the spot.
Yep.
We also marked the probes, so where this one says, let's look for a better example. This one right here, for example, says SMU4.
Nice.
And we know for a fact that that is plugged into the SMU4 port in the back.
Yeah.
And SMU right there. So basically, the tape does correspond to the proper ports, so we know that for sure in this file now.
Cool. So we're all set up here. We have this one on. Next, we just use. So it's connected to this computer right now. It's we have like it's called a GPIB cable connected, and then we have it going to USB.
Okay.
So the program you're gonna open is Easy Expert Desktop. So it's gonna be the blue of the earth, basically. So we have it open over here. I guess the first thing that we would try to do is we have a bunch of test setups already. There's a bunch of standard ones on the left side, but we like to import, and then it's going to be under SPA backups. So we already have like set templates in there. One of them that we can do now is IDS Fiji sweep, which is basically your gate voltage and your gate current or your source to drain current.
Okay.
So this is the basic one we use for our graphene devices.
Did that come default with the system, or did you guys custom?
Oh, so we custom set it up.
Okay.
If you want to make your own later, you can go to export test setup after you set up everything here.
Okay.
And then you can save it as your own, like Chuck's thing.
There. Is that so this other computer down here that uses this screen, is that set up also on that computer, or?
It could, yeah, this software set up. So if you move the USB cable, then you could use it on this, or the file, file you would have to transfer.
That's the only one with the internet connectivity. Okay, you know what, we have 10 revs, we can figure that out.
So USB maybe if you want to switch it over, right?
Okay.
And then, so the main thing to check is your SMUs. So for now we have 1 and 4 for our drain and our source. So those are your 2 conductive areas on your transistor.
Okay.
So can you check that real quick?
1 and 4. Yes.
Okay.
So yeah.
What does that say on it?
Oh, so I'm not sure about that tape, but it's the masking tape is the one that's accurate. I know that for sure. So the masking tape that's actually attached to these gray cables is, or at least was accurate last semester, unless someone's moved it. We probably should check just in case. But
I have 2 over here, actually.
2 over there, okay. And then 4 is probably the back one.
so it looks like 2 is our gate, right?
Gotcha.
We have 2 and 3.
So we can switch that over here. So you just go down to SMU2.
Okay.
And then next you can go to measurement setup. So we have 3 active probes, right? We have our source and drain, and we have our gate as well. So next is measurement setup. So this kind of goes over your sweep variables.
Sure.
So we have like our gate sweeping from -5 to 5, which is okay with us. You have your compliance current. Basically, if that node goes over this current, the experiment's going to stop. So in case the experiment stops prematurely, you know why.
Okay.
And then we have our drain voltage, which is sweeping from 100 millivolts all the way up to 300 millivolts.
What's the reason we want compliance current?
It's good for, like, especially if you're using graphene, like, in case you accidentally put like a high voltage or you're shorting something.
Okay.
You don't want to get that current going through and breaking your device.
Oh,
basically.
I see. Okay.
So that's pretty much it. Function setup. This is where you can set up your variables.
Sure.
So you basically take in your variables from the channel setup. So we use like VD, IS, and we just use those to make your resistance. And then once you have these variables, you add them. And
These will make your plots.
Exactly.
Okay. So what are our plots? Which plot will help us to see the Dirac peak that we're looking for?
Yeah, so gate voltage will be your x-axis, right?
Okay.
And then do you know what will be the y-axis?
So it can be drain current?
Yeah,
Okay.
exactly. Or you can do resistance, whatever's easier. And then make sure that all your variables are here as well for the lists display.
Sure.
So basically when the SPA saves all the data, it's going to go inside here. So whatever variables are here, that'll save over. We can export that later to Excel and we can plot it
Sure.
on our own. But unless we save it here, that's not going to be saved. We're only going to get the plots.
Oh.
And then go to play. So it's actually going to run.
Okay.
And then let's get our updated values. Let's see. So it looks like we're getting some current. We're not getting the direct peak, which is okay. Just an
Right.
example. What you can do too is you can also, you see how there's a secondary variable?
Yes.
You have Y2 and Y3. So if you want to cycle through those, you just click your, this is going to be your secondary variable.
Okay.
And then you can resize, which is the yellow one. It's the auto scale.
And you
So you can
cycle
kinda
through
see-
those by clicking on the right hand side over there?
Exactly.
Okay.
So this is our Y variable 3, right, in green.
Sure.
Yeah. So once this finishes, so it's going to finish at 5, right? We can run I guess we can do a quick append.
Sure.
So especially when we're doing photo response experiments, like if you want to compare the two, we run one first and then we go to the append, which is the play plus button.
Mhm.
And then we can see how it relates to the last one.
Okay.
Sweet. Yeah, does it bring back memories for you guys?
It does.
Yeah.
It does.
Okay,
It's
good.
definitely a good refresher.
Yeah.
Honestly, at the end of last semester, I had gotten complacent and I just used the file over and over and over again. And it doesn't really help because you don't know the background, you don't know why. You just know what you're clicking.
Yeah.
You know?
Okay, so it looks like the second one's about to finish. And then if you ever need to stop it for any reason, you're gonna go to right over here.
Okay.
Close it, abort.
Sure.
So what we can do now is, assuming that we change the settings or we're going to change the experiment a little, we can run the same thing. So the pens is going to be in purple.
Yeah. Did you send your signature sheet?
And then we can see it over here as well.
Did we do a
see.
disclosure? I don't remember.
So yeah, we have our pen going and then pretty
Sure.
much finish that up. And then once you're done with your
I think
experiment,
so.
uh,
I think.
what we can do now is we can save
I
it.
just don't remember.
So this is the one we just finished. It's the IV
That was one
sweep
of the older
on
ones.
2-7.
Yes.
Let's add a comment. So right click it. We'll go to edit, flags and remarks. So we can say this is test with Ian Shock.
Okay.
And then the
I
next
think
step
That's
would
where
be,
we were recording last year, like our, basically what was composing our dielectric when we were running different tests.
Yep. So what you can do now is you want to export it maybe. So you connect your USB onto the side.
Sure.
You right click this or whatever you're interested in. You're going to go to transport data. You want to export as CSV.
Okay.
So CSV is really easy for MATLAB.
Comma separated values.
And then
It's
whatever
like
you
a
want to name it.
Microsoft Excel type deal.
Yep, exactly.
Okay.
And then you can just export. So if you had your USB in there, you would just push everything to that area.
Okay.
So this is the main test that we usually do and what you guys will do. But there's also a time versus current test. That one's really
Okay.
important. So that's for photo response, you want to do time interval, right? So you can see the pulses as well.
Sure.
So we're going to go to same thing, import. Ian, you can lead this one. So we can do like a IVT sampling, and then you can choose 3 terminal. So we have a gate on there as well. And then so you can see, make sure that all our ports are correct, right?
Was it 1, 4, 2, 2 is right?
Yeah. And then you can move over to measurement setup. Let's see. So you can see the big difference now is that you're actually setting, is that IVT? Let me check real quick.
And
This is the
then
measurement variable 2. Let me try again. It might be another one. Oh yeah, try this one actually. I think that one got re-added. So we're gonna add the gate there. And then just so you know, so we usually do voltage, right? Which is, it's easier for us to source, but you can also
Right.
source current if you want.
okay.
And then common is just whatever the ground is for the equipment, it's going to be there. So if you want something at 0, we usually just use that.
Okay. That makes sense.
No variable. And then so Ian can go from here. So you can see what the big differences are now, right? So instead of sweeping voltage, we're sweeping.
We're doing the sample over time.
Exactly, yeah.
Okay.
So you can set your interval time, your total number of samples, get your total sampling time on there.
Mm-hmm.
You can also see for the constants that we set, the 2 voltages on the source and drain, you set them over here. So on your source, so currently Ian has it set up that the drain is getting 0.5 volts
Mm-hmm.
and your source is getting 0 volts. But he can change that as he wants as well.
Okay. And how would we test for gate leakage?
Gate leakage, good question. So
Yeah.
you would actually, it would be more on your display setup. So you see how Ian has his drain current and his drain resistance.
Yes.
What do you want to add here, I guess?
It's like, looking for it.
Mhm.
What did you say?
Gate leakage.
Gate leakage. So we'll have to do it gate voltage. Would it?
Gate voltage or gate current, actually, it would be easier, I think,
Oh,
because you're
what?
going to set your
Okay.
gate current, your gate voltage. So nice. And then it looks like Ian's all set up on the left side too. He has all his variables. So I guess aside from that, I think he should be good to run. Okay.
So all you need is this to be on.
Yeah, exactly.
Okay. We're just gonna auto fit this.
Yeah.
See what it's actually doing. Keep clicking auto fit basically here to to make the picture look nicer.
And then if you guys ever get that error, like when you try opening it and it gives you that error, like it can't run, it says abort, all that means is you have to reset the SPA and then reset this device or this program.
Okay.
It's some kind of calibration error.
Okay.
So yeah, I think that's
Probably
pretty
long
much
enough
it.
to run where we can see what the thing's actually doing.
Yeah.
Okay.